So what the natural killer cell does, and now take a look at this, they are not phagocytic cells. They are not Pac-Man cells. They're not taking in a pathogen. Instead, what they are doing is they're secreting toxins onto the cell surface. Things like granzyme, which is an enzyme that basically infiltrates the damaged cell and causes it to destroy the cell. But it's not a phagocytic process, it's a chemical process. So that's why it's listed as cellular, but make sure that you understand they're not phagocytic and they're not specific. They're targeting damaged cell cells. So tumors and viruses.
Who does the perforin?
They do perforin as well.
Okay,
So the
so-
perforin punches the, I'm glad you mentioned that because obviously I forgot. The perforin punches the hole, then they dump in the granzyme, which destroys the cell. And that's also how cytotoxic T cells work. But that's another chapter. All right, are we okay with that? So then how do phagocytic cells recognize microbes? How do they know who is and is not supposed to be there? Well, that brings us to the acronym of the day, which is PAM. PAM, P-A-M-P. And if you think about what these words mean, you'll never mix them up. Pathogen, associated, molecular, pattern. Are they present on the good guys or the bad guys? Say what that acronym stands for to me. Pathogen, associated, molecular, pattern. Good guys or bad guys? They're on the bad guys. They're associated with the pathogen. And so what we find with bacteria in particular, they have some weird components that our cells don't have. We know of one big one already, which is the cell wall, the peptidoglycan. We don't have any cells with peptidoglycan, so that's automatically a red flag. They also produce other types of kind of big, repeating sorts of molecules and proteins and so forth that are never associated with human cells. Flagellin is one of them. We have cells with flagella, or some of us do, right? The best example of a human cell with flagella. A sperm cell, right. But remember when we were talking about cell structure, we said that bacterial flagella are made of different things. They are structurally not similar, and that's what allows that to be a recognizable pattern. Other things like lipopolysaccharide, lipid A, all of those things that allow us to selectively target bacteria serve as molecular markers for our cells to recognize. So if the pathogen-associated molecular pattern is associated with the bad guys, what do the good guys have that allow them to recognize those patterns? Toll-like receptors. So toll-like receptors go with the good guys. They are the receptors that recognize the molecular patterns. Make sense? And I make that distinction. I know it's kind of elementary and it's kind of vocabulary, but I want to be clear about the distinction because students mix them up all the time. TLRs are on our cells. They help us to recognize pathogens. Pathogen-associated patterns associated with bacteria. Are we okay with that? Yeah? Okay, good deal. Phagocytosis, I mean, what do we need to say about this? There's a whole bunch of stupid words in here that you really don't need to worry about. Here's the, what the hell is a phagolysosome and a residual body no. You've got a cell that encounters a pathogen. A phagocytic cell engulfs the pathogen, and now it's in a vesicle. You're floating around. The lysosome comes over, and the lysosome is filled with what? It ain't filled with peroxide. Hydrolytic enzymes? That's what she meant. That's what I meant. It sounds like peroxide, right? What does it mean to be hydrolytic? Using water to break it apart. Remember hydrolysis from chapter 2 of ANT 1? I hope. hydrolytic, breaking apart. So you have this vesicle with the pathogen, you've got a lysosome, they fuse together, the hydrolytic enzymes destroy the pathogen, and then most of it gets secreted outside the cell as waste product. But later on, we're gonna find that some of these pieces of pathogen are used as flags, so that the cell that takes in the invader holds up a piece of it and says, look what I found, somebody needs to come and check this out, and that's part of the adaptive response. But phagocytosis is considered innate because the Pac-Man cells are not discriminating about who they're eating, essentially. All right, inflammation we mentioned already. How does chronic differ from acute?
Chronic is eating ongoing, acute is short-lived.
Yeah, I mean, see, that's what I'm saying, this is easy stuff, this stuff you already know. If it's acute inflammation, it's happening quickly, and it's typically of a short duration. Usually it's again, typically beneficial. Chronic inflammation is long lasting. If inflammation from certain diseases like systemic lupus, fibromyalgia, irritable bowel syndrome, if those things continue unchecked, they can lead to disease through tissue damage. So long-term, often difficult to control because it's mediated by the immune system. So when you start messing around with the immune system and suppressing the overall immune response, now you've got other problems you've got to contend with. Does that make sense? So tell me, what is probably the, I would say the best, give me an example of a powerful anti-inflammatory medication. Say what? Epinephrine, kind of, sort of. What else? You were gonna say prednisone. Prednisone is a great anti-inflammatory because if you've got a sore soft tissue injury and you get a cortisone injection, it's prednisone, same thing. It's gonna feel better really fast. What is the danger of having someone on prednisone long term? Kidney function can be impaired. What does it do to their immune system? It starts to suppress it in an effort to you're keeping the inflammation at bay, but as a trade-off, you're suppressing the immune response as well. Yes, it does. It does because of the immune suppression. You got that right. Very good. Okay, are we okay with this? This just shows vascular permeability and all that good stuff. How about tissue repair? We don't need to do too much of that. You know that inflammation assists with tissue repair. How? Yeah, because of the leaky vessels and the fluid movement, you're basically getting the repair materials to the site a lot faster. Very good. And I won't ask you about the blood clotting and the granular tissue and all that. I want you to know what inflammation does. So in terms of the vascular response and all that. Okie dokie? All right, so this concludes our adventure into innate immunity. And again, it's easy stuff. It's stuff you've seen before. When we come back on Tuesday, we'll start with adaptive. I will probably give you another fillable thing to do. Do you like those?
I think you already did.
For adaptive, I did? I may have, I don't know.
I'm pretty sure I pretty much.
Do y'all like doing those?
Do you have one for 15?
No.
Be a little more specific on what we should know?
And I'm glad you mentioned that, Mikey. For 15, it's just the bold print words in the text. That's
And
all
then
it
in the
is.
book,
Yeah.
there's a lot of bullprint words in that chapter.
I'll narrow it down for you. Will that help you?
Well, that's what I was getting.
Okay, yeah, I'll narrow, I glanced at it. I'll narrow it down for you and post that. I'll try to do it as soon as I can. I'm kind of,
Well, we got till spring break, after spring break.
Emily,
right?
did
oh,
you,
yeah.
Emily,
Yeah, I'm still.
did you do the outline?
Yeah, I'll narrow those words down for you. A couple of people have asked about the homework stuff. I don't wanna go backwards with the homework. I feel like, if you miss 15 and 16, okay, the world's not gonna end. Right now, it's not a zero, it's not affecting you. But I don't want you going backwards. I want you to keep moving forward with the immune stuff. I want your focus there. If those missed points turn out to be an issue at the end of the semester, then we'll revisit it. But right now, let's not take that many steps. Let's keep going forward. So do you like the fillable stuff? for the chapters, does it help you kind of get through? Okay, so I'll make sure you have that adapted. And I have your test, so if you have not taken this test, you need to skedaddle. You're dismissed, but if you want to review your test, I think you should, because